Hey guys, for today's lesson, we're going to talk about two different types of transformations, the translation and reflection. So a lot of these transformations should be fairly familiar to you from 8th grade, or maybe 7th grade, but we're going to kind of touch on them again, go a little bit more in depth, but today we're just going to focus on the translation and reflection. So overall, a transformation is an operation that maps or moves a pre-image to a new image. So when we have a pre-image, the pre-image may have points A, B, and C. That's your pre-image. After you transform the image, the transformed image is called the image. And it's going to have these little tick marks for notation. So it'll be A prime, B prime, and C prime. And this is going to be able to tell me which one was the before and which one was the after. So make sure that you pay attention to the primes to see which one's before and which one's after. There's also something called an isometry. An isometry is a shape that maintains orientation and direction, orientation and shape when it's transformed. So for example, a translation is an isometry because the shape simply is just sliding over to the right, and a reflection is also an isometry because you still have the same shape, same size. Similarly, a rotation is, but notice for a dilation changes shape. So this one's actually not an isometry. Okay, so first one we're going to go to is a translation. Don't get confused by the letter H and the letter K. This just means we're going to have a shift. So your translation is a slide where it's going up and down and left and right. So when we talk about an H and a K here, not the circle H and K, but just means that we're adding some value to X and adding some value to K. So if I have X plus, like let's say 3, that means you're going to go right 3. So you're adding 3 values to your X value. If you were to have X minus 3, that means you're going left 3. So no shifting here for translations. Just what you see is what you get. Y plus 2, for example, means we're going up 2. And Y minus 2 means we're going down 2. Notice this notation right here. You've got a capital T with parentheses. This is going to be your pre-image. And this little arrow is telling me I'm transforming it in some way to where this value is your image. So let's look at a few examples that we could have. You've got perform the translation, the slide, 3 units left and 1 unit down. So if we're going 3 units left, our original shape is XY, and we're going 3 units left, which means we're going negative. We're going to the left. So that's X minus 3, and we're going 1 unit down. Again, down is negative, so Y minus 1. And you can transform every one of your values just using that rule. So X minus 3 would be 3 minus 3. And I'm going to write this out, but you won't have to actually write it out for every single one. So that gives me 0, 3. Okay, and then we have B, again, just writing what those original values are. That looks really bad. Let me write that. Negative 2. And we're just subtracting 3. So 4 minus 3 is 1. Negative 2 minus 1 is negative 3. And then the last value, C, 0, 2. Subtracting 3 is negative 3. 2 minus 1 is 1. Okay, so each one of those points are going to be your pre-image and then your image when it's transformed. So this will be your A prime, your B prime, and your C prime. Okay, another type of example is I could give you a graph. So each one of these points are already plotted for us, and we're going 1 unit right. So we started our X and our Y. We're going 1 unit right, so that's adding 1, so X plus 1. And we're going 5 units up, so that's adding 5 units up, Y plus 5. So each one is sliding 1 over, up 5. So 1 over, up 1, 2, 3, 4, 5. Plot a point. And whenever you're using the graph, just make sure that you actually notate what's the changes with your primes. Up 1, 1, 2, 3, 4, 5. There's my B value. Over 1, 1, 2, 3, 4, 5. C prime. 1, 1, 2, 3, 4, 5. And it should look, because it's an isometry, it should look the exact same as the pre-image. It's not changing size. It looks the exact same. So here we got a little parallelogram. All right, another type of question that I could ask you is write the rule. So here I gave you the pre-image and the image. Again, see how there's little primes here? That's how you know the difference between the two. And it wants to know how each one of these points is changing. So ask yourself, how do I get from -4 to 2? Well, since we're adding and subtracting, the only way that I can get from -4 to 2 is by adding 6. And I might say, how do I get from 0 to -1? And when I'm talking about the -4, that's the -4 that I'm referring to. When I'm talking about the 0 here, that's going to be this 0. So the first line is kind of your x, change in x's, and the second one's your y's. So just to kind of look at those real quick so you know which ones I'm talking about. Okay, and that is going to be by subtracting 1. So my original thought is that it's going to be x plus 6, y minus 1, which would be right 1, or right 6, excuse me, and down 1. And I would say something like a translation, right 6, down 1. And before you, even though we just looked at one point to see this, you want to make sure you check it for every one of them. So Q from -5 to 1, yep, adding 6. Down 1, 5 to 4, subtracting 1, so that was good. Adding 6, subtracting 1. -3 plus 6 would give me 3, again, good. 5 minus 4 would give me 1. Okay, and the very last type of problem that I could show you is I could give you the graphs. The biggest part about this here is you want to make sure that you're looking to see what's the pre-image, what's the image. So the pre-image is going to be the ones with my no primes, and the image will be the ones with my primes. Okay, and it wants to say what's happening, what's the change. And I just pick one of these points to actually look at. So I go over left 1, 2, so -2. And down 1, 2, 3, 4, 5, 6, so down 6. And we might want to check it just to double check. We go left 2, down 1, 2, 3, 4, 5, 6, good. So x, y becomes x minus 2, y minus 6. Again, don't get confused with the circles equations where we were adding and subtracting values and changing what they looked like. What you see is exactly what you get. So if I was actually to draw a graph, just to kind of remember, if I go left, that means negative. If I go right, that means positive. If I go up, that's positive, and if I go down, that's negative. Okay, just a little refresher on translations. Hopefully these ones aren't too bad. These should probably be the most familiar ones. In the next video, we're going to look at reflections. Again, not a difficult one, but maybe just some refreshers that you'll need to have.